Hello, welcome to ANS Solver. This is the first question of the paper. So as you can see, a coin is thrown 100 times. It shows heads with 60 times. We need to calculate a 98% confidence interval for the probability P and show that that shows heads on any throw. So for this, you need to know a very important formula that is called as the proportion concept, because you are testing, not testing, basically you're seeing the probability of success where you get 60 over 10. So you need to say that this is actually equal to mean equals to the probability of success, and your variance equals to PQ by N. Okay, this is what you need to know, because this is population proportion, where Q basically is the probability of failure, which can be written as 1 minus P. So let's calculate P first. P is basically 60 over 100, because basically you get 60 times over 100 times. So you basically get 0.6. And now, your standard deviation is the root of PQ by N. So your standard deviation can be written as root of P, which I know is 0.6, into 1 minus 0.6, which I know is 0.4, over N, which is 100, because I know it has been thrown 100 times. So now I can calculate my standard deviation on the calci simply. Okay, so the root of 0.6 into 0.4 over 100. So the value I get is simply 0.04898. Now what I need to do is I need to calculate a 98% confidence interval. So this is something like this. 98% confidence interval means this area here is 0.98 in the middle, and obviously if that is 0.98, I know 1 minus 0.98 is 0.02, which can be split as 0.01 and 0.01, because it needs to be equal. Now I know I want the upper Z value and the lower Z value. For the upper Z value, I need the area below it, which is basically 0.98 plus 0.01. So 0.98 plus 0.01 basically gives you 0.09. 0.99, sorry. So now you go on the table of critical values, this page 10. You come here, if you see there's a probability of 0.99. If you see the corresponding Z value for that is 2.326. So you can simply write 2.326 here and minus 2.326 here. Okay, so now what I can do is I can write this formula as the upper Z value equals to the lower x value, minus the mean, which is P here, over the root of PQ over N, which we have calculated. Now the upper Z value is 2.326, which is equal to the upper x value minus 0.6 over 0.04898. So now I can simply calculate my upper x value, which is 2.326 into 0.04898. So 2.326 into 0.04898, and I can add this by 0.6, and when I click on equal to, the value I get is 0.714. Now for the lower Z value, my formula is x lower minus P over the root of PQ over N, which can be written as minus 2.326 equals to the x lower minus, I know the P is 0.6 over 0.04898. So I can simply write this as minus 2.326 into 0.04898, and I can add 0.6 to this. So the value I get is simply 0.486. Now my confidence interval is written as the lower limit, comma the upper limit. So I can write this as 0.486, comma 0.714, which is the final answer of the question.